The the HTTP cache stores a response associated The HTTP cache stores a response associated with the request and uses the stored response for subsequent requests. There are several advantages to reusability. First, since there is no need to deliver the request to the origin server, then the closer the client and cache are, the faster the response will be. The most typical example is when the browser itself stores a cache for browser requests. Also, when the response is reusable, the origin server does not need to process the request, so it does not need to parse and route the request, store the session based on the cookie, query the DB for results, or render the template engine. That reduces the load of the server on the server. Proper operation of the cache is critical to the health of the system. In the HTTP cache inspect, there are two main types of caches: private caches and shared caches. A private cache is a cache tied to a specific client, typically a browser cache. Since the stored response is not shared with other clients, a private cache can store a personalized response for that user. On the other hand, if personalized contents are stored in a cache other than a private cache, then other users may be able to retrieve those contents, which may cause unintentional information leakage. In a response contains personalized content, and you want to store the response only in the private cache, you must specify a private directive. Personalized contents are usually controlled by cookies, but the presence of a cookie does not always indicate that it is private, and thus a cookie alone doesn't make the response private. The shared cache is located between the client and the server and can store responses that can be shared among users. And the shared caches can be further subclassified into proxy caches and managed caches. In addition to the function of access control, some proxies implement caching to reduce traffic out of the network. This is usually not managed by the service developer, so it must be controlled by appropriate HTTP headers and so on. However, in the past, outdated proxy cache implementations, such as implementations that do not properly understand the HTTP caching standard, have often caused problems for developers. Kitchen sink headers like the following are used to try to work around old and not updated proxy cache. Implementations that do not understand the current HTTP caching spec directive, like no control. However, in recent years, as HTTPS has become more common and the client-server communication has become encrypted, proxy caches in the past can only tunnel a response and can't behave as a cache in many cases. So in that scenario, there is no need to worry about the outdated proxy cache implementation that cannot even see the response. On the other hand, if a TLS breach proxy decrypts all communication in a personal in the middle manner by installing a certificate from a certificate authority managed by the organization on the PC and performs access control, etc., it is possible to see the contents of the response and cache it. However, since certificate transparency has become widespread in recent years, and some browsers only allow certificates issued with an signed certificate timestamp, this method requires the application of an enterprise policy. In such a controlled environment, there is no need to worry about the proxy cache being out of date and not updated. Managed caches are explicitly developed by service developers to offload the origin server and to deliver content efficiently. Examples including reverse proxies, CDNs, and service workers in combination with the cache API. The characteristics of managed caches vary depending on the product deployed. In most cases, you can control the cache server's behavior through the cache control header and your own configuration files or dashboards. For example, the HTTP caching specification essentially does not define a way to explicitly delete a cache, but with a managed cache, the stored response can be deleted at any time through dashboard operations, API calls, restarts, and so on. That allows for a more proactive caching strategy. It is also possible to ignore the extended HTTP caching spec protocols in favor of explicit manipulation. For example, the following can be specified to opt out a private cache or proxy cache, while using your own strategy to cache only in a managed cache. For example, managed cache uses VCL logic to handle cache storage, while service workers in combination with the cache API allows you to create that logic in JavaScript. That means if a managed cache intentionally ignores a no store directive, there is no need to perceive it as being compliant with the standard. What you should do is avoid using kitchen sink headers, but carefully read the documentation of whatever managed cache mechanism you're using, and ensure you are controlling the cache properly in the ways provided by the mechanism you've chosen to use. Note that some CDNs provide their own headers that are effective only for that CDN. For example, surrogate control. Currently, work is underway to define a CDN cache control header to standardize those.